Okay, so using Objective 5 and 3.5 is using transformations to graph rational functions. You can use the transformations when they're written like this, but you've got to know a few little things about the parent function for the rational functions. Alright, so our parent function, when we graph it, it's going to have a horizontal asymptote at y equals 0. It's going to have a vertical asymptote at x equals 0. Its graph looks something like this. And it goes through the ordered pair 1, 1 and negative 1, negative 1. Okay, so if it's 1 over and then it has like x plus or minus a number and then it can have plus or minus a number at the very end there, you can use those transformations to graph that. You're just going to shift those asymptotes as well as shift those 2 points that you've got in order to be able to regraph it, okay? So, let's look at 5 here. 5 says that we've got, it says use a graph of f of x equals 1 over x, so graph g of x equals 1 over x plus 2 minus 1. So remember this x plus 2 is, that plus 2 is with the x in that denominator, okay? So it's going to affect our x values, and anytime it's trapped in with x, it's going to do the opposite of what it's supposed to, or what it says. It says x plus 2, which we know means it's going to go to the left 2. And then this minus 1 is not with the x, which means it affects my y's. It's being added or subtracted, so it's a shift. So this would be a vertical shift down 1. Alright, so if I'm going to do that to this graph here, let me draw me another graph. I'm going to shift those asymptotes first. So I can see it said it's going to go to the left 2. Alright, so we're going to go to the left 2, so that means that vertical asymptote is now over here at x equals negative 2. And it said it's going to go down 1, so that means this horizontal asymptote is going to move down 1. And so it's going to be at y equals negative 1. Now remember, we said we had those 2 ordered pairs, so if we wanted to make a table here, we would have the negative 1, and 1, 1. So if I use a table, remember, if we're going to go left 2, that means we're going to subtract 2 from our x's. Go down 1, we're going to subtract 1 from those y's. So I'm going to take both of these x's and I'm going to subtract 2. And then I'm going to take both of those y's and I'm going to subtract 1. And so those would be my 2 new ordered pairs that I would use to help me be able to try to trace or be able to graph my function. And so I know this piece would look like this. This one's going to look like this. They're just shaped by their asymptotes. And so there is our graph. Now you could check it because you know that your vertical asymptote is the denominator set equal to 0, right? So for my vertical asymptote, if I take that denominator and I set it equal to 0 and solve it, my vertical asymptote is at x equals negative 2, which is what we said. Now the horizontal asymptote's a little bit harder to see because you have 2 different terms. And so you would actually have to combine those 2 together to make it one term in order to use the way we learn to do horizontal asymptotes. And I'll show you how. You don't have to do it when I say to use transformations, but just so you know. So we could take the 1 over the x plus 2 minus 1. We're going to have to find a common denominator. So remember that 1 is just over 1. You find a common denominator by multiplying your 2 denominators together. So we're going to multiply this first denominator by 1, and what we do to the bottom of the fraction, we have to do to the top as well. We're going to multiply the second denominator by the x plus 2, and what we do to the bottom of the fraction, we have to do to the top as well. So we're going to multiply the numerators, and we're going to put them over our common denominator. So I'm going to work this out over the common denominator. So 1 times 1 is 1. And then I'm going to distribute this negative 1. So I have minus x minus 2 over that common denominator, which is what we got when we multiplied them. So I'm going to combine like terms in the numerator. So I got negative x minus 1 over, multiply the denominator, that's x plus 2. So if you're looking for that horizontal asymptote, remember you're looking for that highest power of x. Well, this one, it would be on both of them. So we know it's a ratio of their coefficients. So it's going to be y equals, and you have a negative 1 over 1, which means we get y equals negative 1 is our horizontal asymptote, which is what we said it was going to be as well. Okay, so it's just a different way to graph it. We don't see it this way a whole lot, but this is just so you know it is there. So let's try 5. Pencil problem 5. Alright, so let me erase some of this, because I want to leave my information about my parent function up over there, the 1 over x. Alright, so just let me erase what I used that room for. Alright, so what is this going to do to my graph? What is the plus 1? Well, it's inside with x, that means it's horizontal. It's being added or subtracted, so it's a shift. Plus 1 means it's going to go to the left one. This here is not inside with x, which means it's vertical. It's being added or subtracted, so it's a shift. It's a minus 2, so we know it's going to go down 2. Alright, so let's draw our graph here. Uh-oh. Let me try that again. I got to straighten my iPad up here so I can see a little bit better. There, it's a little bit. Sorry. Alright. So I'm just doing 5 each direction. Alright, so we said we're going to go to the left 1. So that means my vertical asymptote is going to shift to the left 1. And we said it's going to go down 2, so my horizontal asymptote is going to be down here at negative 2. Then our table, our x's, it says it's x plus 1. We know we're going to do the opposite, so we're going to subtract 1 from our x's. And then we have the minus 2, so that's going to affect our y's, so y minus 2. So we're going to take our x's over here, and we're going to subtract 1 from them. We're going to take our y's over there, and we're going to subtract 2. And then we're going to plot those points. And then we shape it using our asymptotes. And there is our graph.